One of humanity's greatest achievements, one that sets us apart from any other living being, is the invention of mathematics. At first, it evolved from a need to count things, like bones, rocks, people, or items to trade, but it soon developed into something much greater. Civilizations all over the world quickly learned how to add, subtract, multiply, and divide, and from there they predicted the orbits of planets, find the laws and forces of nature, and even tried to find a theory of reality itself. Over time, people grew acquainted with the many different aspects and symbols used in math, and it became arguably the most useful tool that we have, retaining that title even today. Without mathematics at our disposal, we would never have many of the things we have today, like the computer or the phone you're using to watch this video. Not only is math a very useful tool in our daily lives, but with it, we can understand the entire universe. You can think of it as a sort of universal language. No matter where you go in the universe, here or 10 billion light years in that direction, 1 plus 1 will always equal 2. It's common logic. Even if aliens exist and live on another planet, they will still use the same mathematics as we do, except with different symbols. And if reality is made of information at a fundamental level, mathematics may really be all that our universe is made of. This was an idea put forward by Max Tegmark in his book, Our Mathematical Universe. This idea, called the mathematical universe hypothesis, states that all of reality is made of mathematics, and even consciousness can be described as trillions of equations playing out at every instant. However, in this video, I will show you a new and different type of mathematics, called Symmetry Mathematics by Gevin Giorbran, that changes our perception of math, and maybe even the entire universe. Part 1. The Sum of All. Symmetry mathematics is a very new and very interesting type of mathematics. Understanding it will take a great mental shift from our ordinary perception of math and the universe, so get ready. First, let us ask the question, what is the sum of all numbers? If we took every possible number, positive or negative, real or imaginary, and summed it all together into one ultimate number, what would it be? Infinity? Well, all of the positive numbers would sum to infinity, and all of the negative numbers would solve to negative infinity. So the question is, what is infinity plus negative infinity? The answer is, surprisingly, 0. 0 is the sum of all numbers. However, following this logic, if 0 is the sum of all numbers, then technically 0 is not nothing. In fact, 0 would be every possible number that exists. Instead of being nothing, 0 would represent everything. Gevin Giorbran says, wouldn't that be strange if the sum of all numbers somehow equaled 0? We could then say that 0 represents the everything of math, couldn't we? And that wouldn't really make sense, because the meaning of 0 is very related to the word nothing. If what Gevin is saying is true, then mathematics may be deeply flawed. And to stop that, many mathematicians say that the sum of all numbers is undefined, and then the world of math is all well again. But what if the sum of all numbers is 0? Imagine that for a moment. If this is true, and keep in mind that mathematically it is technically true, 0 would be the largest number of all. It would be the biggest number that can ever exist, far from being nothing. And so the entire number line must be torn apart and stitched back together in a completely different way. As Gevin Giorbran says, if we test 0 to be the sum of all numbers, we must allow its usual value of nothing to change to a value equal to the summation of all numbers, which means we assume 0 to have a value greater than all other numbers. Do you see what I am saying? It's a bit radical. If we sum all numbers instead of cancel all numbers, we alter the entire value system. Then, suddenly, we have what appears at first to be nonsensical. If 0 is the greatest value, the sum of all numbers, then what is the value of the number 1 or 2? Which is greater, 1 or 2, if 0 is greater than both? Part 2. The symmetry number line. If we assume 0 to indeed be the largest number in mathematics, then we end up with a whole new field of math, called symmetry mathematics. But what, then, is the value of ordinary numbers, like 1 or 2? In normal math, all numbers get their value from 0, which acts like a placeholder. Normally, positive numbers are greater than 0, and negative numbers are less than 0. But in this case, both positive and negative numbers are actually less than 0. So what is the value, then, of 1 or 2? Suppose we take a 1 away from 0. What remains in the absence of that number 1? 0 is still very large, But 0 is no longer an absolute value containing all other numbers. Something has been removed from it. But what value does 0 transform into to show that loss? Well, the answer is quite simple. 0 minus 1 equals negative 1, because negative 1 plus 1 equals 0. So the value of 1 is every possible number summed together except for negative 1. Similarly, 2 is every possible number summed together except for negative 2, and so on. And this leads us to create a very strange number line for symmetry mathematics, a symmetry number line. In this not very ordinary number line, 0 is the largest possible number. It is a whole containing within it every possible number that can ever exist, no matter how large. And contrary to regular mathematics, the farther you go from 0, the more numbers decrease in value. In symmetry mathematics, 1 is actually larger than 500 because it is closer to 0. And so if you were to draw a symmetry number line, you would start with an infinity in the middle, aka 0, and decrease in value as you would move outward. But this raises a very important question. If numbers decrease in value the larger they become, what about infinity? Is infinity an infinitely small value? Part 3. Proto and Elea. If the values of numbers decrease as they get larger, and infinity is the largest number of all, then is infinity actually the smallest number? Well, yes. Because infinity is infinitely many digits away from 0, its value is actually infinitely small. The same thing goes with negative infinity. As Gevin Giorbran says, in symmetry mathematics, there is one ultimate value which contains all other numbers, 0, and on either side of it other values decrease. As we count into ever larger numbers, their value decreases toward an infinitely small value. Consequently, the values of larger numbers converge toward two outer extreme points. This clearly visible convergence allows positive infinity and negative infinity to have definite values, so they can be represented as two numbers. And these numbers that Gevin is talking about are Proto and Elea. Proto is the symmetry value of positive infinity, and Elea is the symmetry value of negative infinity. The symbol for Proto is a 0 with a plus sign inside it, and the symbol for Elea is a 0 with a minus sign inside it. In symmetry mathematics, these are the smallest possible numbers that can possibly exist. However, when you add them together, you still get 0, the largest number that can possibly exist. Therefore, Proto and Elea are simultaneously the smallest numbers and half of 0. I know, it's very confusing and it makes my head spin, but it's actually interesting as well. What makes it so interesting is that symmetry mathematics works well with the model of the two orders that I told you about in my last video. If you don't know what they are, check out my video about them. The farther out you go from 0 on the symmetry number line, the more grouping order you find. The closer in you go to 0, the more symmetry order you find, with 0 being the state of maximum symmetry order and Proto and Elea being the states of maximum grouping order. The model of symmetry mathematics, as you can see, is quite interesting and eye-opening, and if it is proved correct someday, it will be very revolutionary to all of mathematics and science. But does this have any implications in the real world? Well, if reality is made of mathematics at a fundamental level, then yes. In fact, symmetry mathematics may change how we look at the world forever. Part 4. The Secret Infinity. Symmetry mathematics is a very interesting type of math, but can it change our perception of reality in any way? It actually can, and quite dramatically. Remember how I told you earlier about the mathematical universe hypothesis, a claim by physicist Max Tegmark that reality is fundamentally made of mathematical information? Well, if this is true, then symmetry mathematics exists in the real world as well. At first, this might not seem too interesting, but remember the one major aspect of symmetry mathematics that makes it different from any other field of math, that the value of 0 in symmetry mathematics does not represent nothing, but is in fact a summation of every possible number imaginable. Apply this to the real world, and you'll find that things we experience as nothing, like empty space devoid of time or matter, are actually the superposition of every possible state of matter. Let that sink in for a moment. This new way of thinking about things changes literally everything about reality. The absolute nothingness that we think our universe came from, and where it will go when it dies, is actually not nothing at all. Nothing is really the superposition of every possible universe, and the Big Bang was just a quantum event that picked one universe out of the infinitely many others. We don't need fancy inflation or bubble universes to explain the multiverse. Nothingness is, in fact, its own infinite multiverse. Nothingness may be simple on the outside, but on the inside it is infinitely complex. And so we are led to the grand conclusion that every possible universe, imaginable or unimaginable, exists in its own way within perfectly empty space, just like how all numbers exist within zero in symmetry mathematics. As Gevin Giorbran says, applying symmetry mathematics to the universe would indicate that what we think of as empty space is really full and not empty. It would indicate that our universe is like a symmetry math number, definite and yet infinite, but not yet the total infinite. Our universe is like the surface of the ocean, and underneath that surface is the rest of the infinite whole. This also means that the creation of our universe was a break from this timeless symmetry, and that our universe is a purpose, a goal, to return to the timeless ultimate symmetry that is nothing, what I will now call Omega. Thank you for watching, and I hope you enjoyed. As always, this video was made by Alexander Rafel and edited by Samuel Rafel and Bhavani Gopal Krishna. The concepts presented in this video were based on the amazing book Everything Forever, Learning to See Timelessness by Gevin Giorbran. As always, if you want more amazing and groundbreaking ideas about timelessness, existence, and the true nature of reality, please visit everythingforever.com or buy Everything Forever, Learning to See Timelessness by Gevin Giorbran. Thank you for your support, and be sure to subscribe and like this video.